this is a booklet I've created by just bringing together most recent papers so that we can be able to have a quick run through of different questions that you have been tested before, and we are going to look at how you are going to approach them so that we can be able to avoid a situation whereby MCQ, multiple choice questions, are going to make you to cry. So we're going to look at most of the questions through this. It's going to be about 250 questions, MCQ recently asked tested questions, and then you can see this paper is going to be having only 40 marks. So by going through all these about 250 MCQ questions, you will be able to get a good understanding on how to answer different topics, and that will be great. You'll be smiling out of the exam room if you have mastered on how to answer different questions. Is that right? All right, so we have said that the first question, or the first concept you need to know, is the difference between vector quantities and scalar quantities. And we have said that scalar quantities are those quantities which can only be described by only size. They have only size. They're described by only size but no direction. And in that case, scalar quantities are like distance, length. We can talk of volume, density. We can talk of time. Yeah, but vector quantities are quantities which have both size and direction. So we can talk of acceleration, we can talk of velocity, we can talk of momentum, we can talk of force, because those quantities, they have both size and direction. And then another aspect is average speed. Average speed is total distance over time taken, and that is going to be part C in that case. If I'm moving faster, you can write in the comment section to slow down, but I believe we have to move a bit faster so that we can be able to ensure that we cover more in this particular live. The diagram shows a series of images of a moving object taken at a regular interval of time, and you can see here we are having equal distances from here to this. We have equal distance, so that means that object was moving at a constant speed at that point. And then here the distance is increasing, so meaning the object started increasing the speed. So that's why you could be able to see the dots quite spaced out. So the object traveled at a constant speed and then accelerates. Plastic ball has a mass of 4.0 grams and the volume of 20 centimeter cubic. There is a crack in the ball surface, and the ball is placed in a bath of water. Water leaks into the ball, so meaning this water is going to occupy a volume of 20 centimeter cubic. So if it's going to occupy, this water inside the ball is going to occupy 20 centimeter cubic, and we are told that the density of water is 1.0 grams. Then if we are asked the mass, we know density is equals to mass over volume, so which implies that our mass is going to be equals to density times volume. So if we the volume that is going to enter into the water through the crack, that water inside here is going to have a volume of 20 centimeter cubic, and the density is 1, so this is going to be 1 times 20, and we're going to have 20 grams up to that point. So the option, the correct answer there is going to be C. Right, moving to the next question here is a satellite. So something that you need to understand is that in circular motion, the only concept that will be tested is the direction in which the force that is keeping that object in circular motion, where is it going to be directed to. So anytime you will be asked, you will understand that the force that is keeping this object in motion around the orbit is always directed to the center. Yeah, so that is it. Even if they are going to ask you a question whereby a car is negotiating a corner, so you are going only to say the force that is keeping this object in track in the circular path is going to be the force directed to the center, right? So the force is going to be frictional force here to keep this in circular motion. and then we are going to have for a satellite going around the orbit is going to be the gravitational force. So in that case, that force is going to be directed towards the center. So we are going to say the resultant force is toward the center of the earth. We have question number 6. We need to understand the object being at equilibrium. An object that is at equilibrium is going to be having a net force equals to 0. So the forces must be balanced in any direction, and the clockwise moment should be equal to anti-clockwise moment. So that's something that you need to remember. So A cannot be correct because this force that is acting here is going to create a rotational motion, and this one also is going to create a rotational motion here. So this one is down, this is up. So the only force that is going to create a rotational motion is this force that is here. So this is not at equilibrium. Upward forces here are 20, downward forces here is 10. So the object is going to experience an upward force of 10 newtons, and this one also is going to experience an upward force because this and this one will cancel out. So the only object that is at balance is this one, which is at equilibrium. Question 7. A resultant force F at that given point All right, so I mentioned that in this particular question, circular motion, whenever there's an object that's moving in a circular motion, the force that, for instance, if a satellite is going around the orbit, the gravitational force is the force that is going to keep that attracted to the earth. So gravitational force will be acting towards the earth so that the orbit, so that the satellite does not go out of the orbit. So for instance, also, if yeah, so okay, if you got the question, that's fine. That's great. So we can be able to proceed. Rose, nimetia maji ya kunywa. Bekire turungi. Mungkin apa sana? Now, the resultant force F accelerates a car of mass along a straight. So at this point, you need to remember the force is equal to mass times acceleration. And we are told that the v and the initial velocity was 0 because it was starting from rest. So if you want to work out the acceleration, it will be v minus u over t. In this case, acceleration in terms of v and t will be this value here. Then force is equal to mass times acceleration, but you can see acceleration is v over t. So if we multiply, F is equals to m times acceleration, it will be m v over t. Then now we shall have if we multiply t both sides, we shall have ft is equals to mv, and that is going to be this particular part. But remember, mv itself, not much. mv itself is momentum. Mv is momentum, so we can be able to say P, which is momentum, equals to mv, and ft is equals to P. Ft is equals to P from here. Mv, so we can say Ft is equals to mv, but mv is momentum P. Yeah, so that's what we are supposed to do. Question number 8, we need to remember the concept of the law of conservation of momentum. And the law of conservation of momentum say that momentum before collision is equal to momentum after collision. I think I've jumped the gun there. We need to remember the law of conservation of energy. I'll talk about the law of conservation of momentum later, but at this given point we shall focus on the law of conservation. Aliteswa naenda taratibu. Okay, all right. So guys, please like the live, just like the live, leave the comment if I'm moving the right pace. If I'm speeding up, tell me, sir, just reduce the speed. I'll be able to do that. I'll be able to do that. So in question number 8, we're going to focus on the law of conservation of momentum. I don't know why I keep on mentioning momentum, but I'm talking about the law of conservation of energy. That energy cannot be created nor destroyed, but it can be converted from one form to the other. So at the highest point we have high gravitational potential energy. As the car moves down, potential energy will be decreasing as kinetic energy is increasing. So which means that at point X we have kinetic energy there as it's moving down from X to Y. It means kinetic energy will be increasing as gravitational potential energy will be decreasing. So because at this point we are having highest gravitational potential energy. So as it's moving from X to Y, as it's moving from position X to Y, what happens is that kinetic energy will be increasing as gravitational potential energy decreases. So the correct answer there is going to be C. Question 9. Still the law of conservation of energy. So we are told that a box initially at rest at the top of a rough slope. The box slides down. The weight of the box is 20 newtons, and then the slope is 4 meters long and 2.0 meters high. So the first thing that we need to remember, the net work done is equal to the kinetic energy, and that net work done is going to be 40 joules minus 10, because we are told that the box does 10 joules of work against friction. So that is going to be 40. And how are we getting the 40? Gravitational potential energy from this height is going to be mgh, yeah, mgh, but mg is the weight, which is going to be 20 newtons. So if we take 20 times 2, we're going to get 20 times 3, we're going to get the gravitational potential energy this box was having when it was at this given point. Yeah, then when it slopes down, it's going to work against gravity. So some of the energy that is going to be lost is part of the gravitational energy will be lost to work against air resistance. So the energy that is wasted is 40 joule, 10 joules. So which means the energy that will be converted to kinetic energy will be the 40 minus 10. So we shall have 30 joules as kinetic energy in that case. So once we have gotten kinetic energy is 30 joules, then we can be able to find also the weight, right? Weight already is given as 20 newtons, so we can be able to work out the mass, and we shall say mass is weight over gravity, and that is going to be 20 over 9.8, which is going to be 2.04 kilograms. And we shall be able to use that mass in the formula for kinetic energy, and we shall say a half times 2.04 times v squared is equal to 30, right? Because when the box was at the top here, it was having gravitational potential energy. Which amount of gravitational potential energy was it having? Is mgh, which is going to be mg is weight, so we are going to say 20 times 2, that is 40 joules. But as it's going to slide down the slope, part of that gravitational potential energy will be used to overcome air resistance, and that amount that is used to overcome air friction in that case is going to be 10. So from the 40 we are going to remain with 30 joules, which is going to be converted now to kinetic energy. So that's why you can see I'm saying I have mv squared is equals to 30, and if you work it out you are going to get our v equals to 5.4, which is going to be our a at that given point. I believe we are okay, right? Great. Can we say k is equals to calculate? No, first that given point early we are going to subtract gravitational potential energy. Of course we are going to subtract the energy that was used to overcome friction, and then we use the 30 joules, we equate it to a half mv squared, which is kinetic energy, then we work it out. I believe you've gotten it right, yeah, at that given point. Yeah, so that is it. In question number 10, we are told an electric car is charged overnight in 8.0 hours. 180 megajoules of energy is transferred. So we need to remember the formula that power is equal to energy over time. So our power, what is the power of the charger? Power must be in joules, must be in watts, but energy should be in joules. So it will be 180 times 1 million, because it was given in megawatts, over time, and time must be in seconds, so it will be 8 times 3600, and that's going to translate to 6250. We convert it to kilowatts, yeah, so that will be 6.25 kilowatts, which is going to be option A. Pressure in liquids is given by P equals to H rho G, height times density times gravity. But if you want to find density, in this case we are going to rearrange the formula, make density the subject, which is going to be pressure over height G, and that is going to be option D. What's Brownian motion? Remember, if you observe a smoke cell whereby we have specks, some smoke inside there, using a microscope you will see the particles of smokes moving in a random motion, because these particles are colliding with invisible air molecules which are constantly in random motion. Then that is why you are able to see the speck of smoke moving randomly in a straight line. Yeah, so this is observed in gases and liquid only, because if you want to observe in liquids, maybe you have a bowl containing some water, and then if you are going to pour some pollen grains on the surface of water, you will be able to see. If you have also a traveling microscope and then your eye is positioned here, you are going to see the pollen grains moving in random motion. And the reason as to why they are moving random motion is because those pollen grains are colliding with invisible water molecules which are moving randomly, and that is what is called Brownian motion. Right, so moving to question number 13, we need to understand pressure against volume. If this is not correct, if it was pressure against volume like that, it will be a graph that looks like this. So this one's not correct, this one's not correct. Then P against 1 over V, it will be a straight line like that. So the correct answer is going to be D there. Any question up to that point? Let me see that in the comment section. Let me see that in the comment section. Question number 14, liquid evaporate from the beaker. What happens to the temperature of the remaining liquid, and how does this temperature change affect the rate of evaporation? So how does temperature affect rate? If you decrease temperature, you are going to decrease the rate of evaporation, because the molecules will have low kinetic energy for them to escape from the water surface. So the correct answer is going to be A. Number 15, thermal energy E is supplied to an object of mass m which does not change its state during heating process. Temperature of the object rises. So we know that thermal energy is equals to mc change in theta, where this is the mass, c is the specific capacity, change in temperature is this. Then if we want to work out specific capacity, we shall divide both sides by m change in theta, and the answer is going to be A in that case. How does a heater cool a room? Remember, when you heat a liquid, the liquid expands, and the moment that liquid expands, it means that the density of that liquid is going to decrease. So the moment you heat a liquid or you heat a gas, it expands and becomes less dense, so it's going to rise. So in this case, when you heat using a heater, the air will expand and it becomes less dense, so it's going to rise, and then cold air will come down because it's more dense to occupy the space that was left. So in that case, we are going to say which diagram and reason explain the heating of a room by convection. This is A, this is X, and the reason is that air density decreases when air is heated. Yeah, so that is why you can see it's rising. So but this one is wrong, because the moment this air that is here is heated, it becomes less dense, travels upward, not the other way. So this is not correct. A student writes down some facts about two transverse waves, and says that wave 1 has a frequency f and velocity v. Wave 2 has 4 times the frequency of wave 1 and is traveling at the velocity of 2v. So the first aspect or the concept that we need to remember is that v is equals to f lambda. This is the wave equation. So if you make lambda the subject formula, so v is going to be lambda is equals to v over f, but our v we are told is 2v, so we shall say 2v over 4f. So if you simplify this, you are going to get your answer as D. Question 18. Question 18 says a straight wavefront of on the surface of a ripple tank approaches a gap, and this is actually called diffraction. When a wave spread around an obstacle, or as it passes through the gap, we are going to call this diffraction of a wave. This is reflection, and for reflection you need to remember angle of incidence should be equals to the angle of reflection, and down here we have refraction, the bending of a wave as it moves from one boundary to another, and we are going to look at that as in question number 19. What is the relationship between refractive index, n of a glass, angle of incidence, and angle of refraction? That is going to be sine I over sine R is the correct answer. Refractive index also you need to remember because we don't know which question will be asked in that exam. You need to remember that refractive index can also be given as speed of light in a vacuum over speed of light in the medium or in the material. Or refractive index can be calculated using the formula 1 over sine c, where c is the critical angle, or sine c is equals to 1 over the refractive index. So for light, those are the formula you need to remember as far as that is concerned. Which diagram shows the image formed by reflection? Remember, images formed by mirrors, they are same size. Characteristics, lateral inverted, laterally inverted, meaning the left is on the right and the right is on the left. Equidistant from the mirror, so this distance here should be equal on the other side. So those are some of the characteristics that you need to remember. Same size, laterally inverted, meaning the left is on the right and the right is on the left. Same size, upright, and so on. Yeah, so question number 21. You need to understand that the distance from the lens here to where the rays which are parallel meet, this is the focal principal focus, but the distance that we have here is what we call the focal length. So which lens has the longest focal length? So you are going just to look at the value of y, which is the largest value, and that's going to be, because this distance y is representing the focal length. This is representing the focal length. The frequency of a microwave used is 2400 megahertz. What is the wavelength? So the only thing that you are supposed to remember here is that a microwave is an electromagnetic wave. It's an electromagnetic wave, and it travels at the speed of light, which is 3.0 times 10 raised to power 8. Then you shall use the wave equation there. So our wavelength will be speed over the frequency, but this frequency is in megahertz, so we shall multiply that by 10 power 6, and if you work it out, you are going to get our answer 0.125 meters, and the answer is A. Speed of sound in a solid is approximately 3000, and speed of sound in a gas approximately 300. Approximately 300. Yes. Question number 24. Hard magnetic materials can be used to make permanent magnets. So let me now check. We are together. I believe we are together up to that point. Let me just get to check if we have left any message in the comment section. Before, we are told a hard magnetic material can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary permanent magnet. So, sorry, a temporary magnet, sorry for that. Which rows show whether iron and steel are hard or soft magnetic materials. So something we need to understand is that iron is a soft magnetic material because it can be easily magnetized, and also it can lose the magnetism easily. And we have steel. Steel is a hard magnetic material because it can be able to retain the magnetism for quite a long period of time. So the correct answer here is C. Moving to question number 5. Moving to question number 5, unless there is a question. Question number 25 says a power source is connected to a resistor XY. Which are the convection directions are conventional currents? In which direction are the conventional current and the flow of free electrons through the resistor? Remember, current flows from the positive to the negative. So current is going to flow from X to Y, but electrons will be repelled from the negative terminal. Electrons will be repelled from this negative terminal, but they will be attracted to the positive terminal. So electrons will travel XY, but current will travel YX, like that. So the correct option in that point is C. Which unit is used to measure electromotive force? EMF is joules. Electromotive force. EMF, units measuring EMF is actually volts. EMF is measured in volts. The graph shows the current voltage characteristics of a filament lamp, and you can see now as the voltage increases, the slope of the graph decreases, and in that case it means resistance is increasing. Yeah, so if the graph was current against voltage, it means that this resistance is what is increasing. we are told that when this rod Q is brought close to R, R moves away. But if you look at Q, is positively charged, so meaning it's repelling this R. So this R also must be having a positive charge, and that's why it's being repelled away. From the law of electrostatics, unlike charges attract, like charges repel. So that is why we're going to say rod R must be positively charged. That's why it's going to be moving away. And you need to remember that materials are charged by rubbing the materials against one another. So question number 29, application of rectifiers. In this case, I'm going to cancel that. Yeah, rectification and using of the diode. Maybe what I can mention, you need to know that this is a symbol of a diode. Yeah, and a diode is a device that allows current to flow only in one direction. So the rest of the part are not necessary as far as your exam is concerned. Okay, so moving to question 30. Question 30 says the circuit shown can be completed by inserting component X and Y. And then we are told that the potential difference across Y increases when temperature increases. So if you are told that temperature, then we are talking about a thermistor, because a thermistor is the only device whose resistance is affected by temperature. So if this device, the potential, the PD here, increases, if the temperature increases, it means a thermistor is placed here. So when a thermistor is placed here, when when temperature increases, its resistance decreases. So if resistance decreases in this section, we are going to have a less potential drop here. There will be a larger PD, high PD here, because there will be less PD here when there is high resistance, when there is high temperature. So we are going to say here, we are going to fix a thermistor, so that when temperature increases, resistance will go down. If resistance will go down, there will be less voltage drop at this point, and therefore there will be a larger potential drop, voltage drop here, and then that is why we are having a potential component Y increases. So we are going to say this is a thermistor, and down here we are going to have a resistor for that case. So for question number 30, we have answered that. For question number 31, we are going to use Lenz's law. Yeah. So we are told the north pole of the magnet is pulled away from X. Then the magnet is now turned around so that a north pole is on the left. A north pole is on the left. So you can see on this magnet we have a north pole on the left and the south pole to the right. Then it's brought to Y, and then it's pushed through the solenoid there, and then a new current is going to be induced. So something that you need to remember, if we are having a north pole here and there is going to be a current induced, the induced current is going to be acting in such a way that it's going to oppose the change causing it. So current is going to flow in the same direction, so you are going to use right hand grip rule, so that if you grip, assume you are gripping, you are holding the coil, these fingers will be carrying around that coil like that, and the thumb is going to point towards the north pole. So the thumb is usually the north pole when you're going to use right hand grip rule. Then the thumb is going to oppose the north pole here. So these fingers will be telling you the direction of the current, and this thumb is telling you the direction of the field. So the north pole is on this side, so it's going to oppose the north pole of the magnet. Then we can be able to deduce that current is going to flow in the same direction and causes the ion to repel. Yes, so the new current, the induced current is going to be in the same direction, causing the soft ion to repel the north pole. So since the thumb is going to be, the north pole is going to be here, it means this north of the induced current is going to repel the north pole of the permanent magnet. Question number 32, the current is repeatedly changed, and then we're going to, what is the effect of the wire? The force on the wire alternates between one direction and the opposite direction. That's why you can see we are having the highest in the positive and the lowest in the negative side. So for transformers, remember we talked about transformers. We have primary coil, and here we have the secondary coil. So we can say number of turns in the primary coil over number of turns in the secondary coil is equals to voltage in the primary coil or voltage in the secondary coil, and that is going to be option B. Also, you need to remember that power in is equals to power out. So which will mean then another formula maybe you can be asked in this exam is that this is going to be current in the primary coil times voltage in the primary coil is equals to current in the secondary coil times voltage in the secondary coil. So you need also to remember this formula, so in the event a question is asked from here, you are able to answer that. A material becomes positively charged when it loses electrons, and also it becomes negatively charged when it gains electrons. So we are told that magnesium ion has double positive charge, so meaning it has lost 2 electrons and has a single negative charge, so it has gained an electron. So in that case, which statement is correct? Chlorine gains an electron to form a chloride ion. Chloride atom loses a proton. That's wrong. Magnesium loses an electron. So it's wrong because we are told it's having 2 positive charges, so it has to lose 2 electrons. So that's why that is wrong. And magnesium atom gains 2 electrons, so if it gains, it's going to become negatively charged, and that's not the case. So we're going to say the correct answer is A. Question number 35. Which law correctly describe an example of radioactive decay? This is unstable, losing an alpha, there is change in element. Stable, that's losing energy, so there's no change in element for gamma. Unstable, no change. This is wrong. There must be a change when it loses gamma or alpha, right? Unstable, no change, so this makes it wrong. So the correct answer is B. And for this question, we're going to work backwards, and we're going to get 20 counts. We have question number 37. What happens to the process of nuclear fission? Nuclear fission is the splitting of nuclei, and that is nuclear splits. Nuclear fusion is when nuclei join together. If you are asked to do a question to do with orbital speed, you need to remember orbital speed is equal to 2 pi r over t, where this is the periodic time and this is the radius of the orbit. So then if we substitute, you're going to get 2.99 times 10 raised to the power 4 meters per second, which is rounding to 3 times 10 raised to the power 4 meters per second as the value for C. Electromagnetic spectrum, which is mostly given by the sun, is infrared radiation and visible light. In that case, how does the sun produce its energy? Is by nuclear fusion of hydrogen, because it's in the main sequence, so it's fusing hydrogen. And that marks the last question. Now we are going to have part 2 of this life. We shall have part 2 of this life. We shall move to the next paper, and these are the questions that we are going to look at. So if you are new to Proflan, consider joining our Patreon page. Consider joining there so that you can be able to download this particular paper, so that you can be able to have it, you attempt it. When we are going to do the second part of this live, you'll be able to check also your questions. See you guys. I believe you've gotten value. See you in the next part of this last minute revision of multiple choice.